Hi, Sophie. So, not too sure what we actually got up to when we did this work together, but we did slam through a fair bit of work on the Friday. So, I'll work you through the rest of the notes or what I feel like we got up to. So, I think that we got up to this question here, state a transformation which maps this graph onto this graph. So, got f of x equals 6, f1x equals root x. Now, what would I drop into f of x to make f1x? So f1x would be f of 6x, I believe. Okay, because when I drop 6x into this, I get 6x over 6, which cancels out, leaving us with just root x. So this will be the way, or a transformation, which will map that to that. Now, what is that? That is a dilation factor 1/6 from y, or the y-axis. All right, so let's get stuck into a few more of these. For y equals f of x, state the dilation for the following. This is a dilation half from x, y rather. This one here is a dilation factor 2 from the x-axis. Okay, determine the equation of the image f of x after it's been dilated by a factor of 4 from the y-axis, dilated by a factor of 2 from the x-axis. Okay, so let's go and dilate by a factor of 4 from the y-axis first of all. So I'm going to call that, it's a new function, that the g of x equals. So factor of 4 from the y-axis means I'm going to do f of x on 4. And 2 from the x-axis means I just multiply it by that. So g of x is going to be that. G of x equals 2 over root x on 4 take 3. Now, sort of a fraction over a fraction here, and VCART don't really like that, so we're just going to tweak this so that it looks as follows. X take 12 all over 4, so times by 4 over 4. And what that allows me to do then is 2 over root x take 12 over 2. Dividing by a fraction is the same as multiplying by a reciprocal, so it's going to be 4 over root x take 12. So there is g of x. After those two transformations, that's what's produced. State a possible sequence of transformations which maps this f of x onto this. So what we'll do is f1 of x can be created, and we're going to do this by recognition. All I'm going to do is multiply this by 2 on 5, negate, and write f of x. So basically, I'm suggesting if you multiply f of x by 2 on 5, what will happen is those will cancel out, and that'll be 1 over 1, and a negative as well. Okay, so a possible sequence of transformations. Let's just try it out. f1x equals negative 2 on 5 times 5 on 2 x squared. So 2 cancels the 2, 5 cancels with the 5, negative equals negative 1 over x squared, which is what was supposed to happen. So what does that transformation represent? It is a reflection in the x-axis, and it is a dilation factor 2/5 from reflection in the x-axis, dilation factor 2/5 from x-axis. Okay, so when we reflect, we kind of, or I apply the same mantra. So reflections in the x-axis change or negate the y values. Reflections in y-axis change the x values. So for the graph of f of x, we have the following two pairs of processes. X comma y maps to x comma negative y dash. So x dash and y dash go up there. X dash equals x, y dash equals negative y. Right, so here's our original. Okay, let's create our image. So our image is going to be negative y dash equals y. So negative y dash goes in, equals f of x dash. Y dash, our image is created by doing negative f of x dash. Right, so that is the equivalent process. Okay, so applying the mapping, we get that. So to do this, okay, or to enact this transformation, we can simply do negative f of x, and that'll reflect in the x-axis. Right, applying this mapping here, it'll be the same thing. We'll go through the same process, x dash, y dash, x dash equals negative x, y dash equals y. Negative x dash equals x, y dash equals y. So let's pop them into that. So y dash equals f of negative x dash. So to do this, which is a reflection in the y-axis, all we do is we drop into the function f of negative x. So this will be a reflection in y. This one here is a reflection in x. Right, so find the equation of the image when the graph of this is reflected in the x-axis. So I'll go f of x equals root x. And to do that, g of x equals negative f of x. So reflections in the x-axis simply negate the function, negative root x. So g of x equals negative root x. In the y-axis, what we'll do is if f of x equals root x, let's drop in g of x equals f of negative x, remembering that that is the reflection in the y-axis. So negative root x. All right, write down the equation of the image of y equals f of x if it's been reflected in the x-axis, if this is our function. Okay, so we're going to reflect it in the x-axis. So g of x equals negative f of x. That means we negate the function equals. So I'm going to negate this function here. Negative, open your brackets, 3, 4, take x all squared plus 4, close your brackets. All of this gets negated, so we distribute the negative sign. So don't forget your brackets here. Negative 3, 4 take x, all squared, take 4. Right, same deal with this one here. What we'll do is g of x is made by doing negative f of x. So we're going to negate all of f of x. So g of x is equal to negative 1 over x take 4, take 2. So that gets negated and that gets negated. Right, now what we'll do is reflect in x and y. So we'll make a new function g of x equals negative f of negative x. So that's both of them. All right, so let's do that. So we're going to go negative, open your brackets, negative 2 take. This one here is going to be negative x, goes in place of x, squared plus 6, close brackets. Okay, so that's going to be negative 2 plus x all squared plus 6. Negative by a negative is a positive, so that's 2 plus x all squared. Negative times a positive is a negative, take 6. So g of x is that after those two transformations. Right, so what we finished up on was combining transformations. Okay, so we got the graph of y equals x squared. Okay, and what we were doing was determining the rule of the image under these transformations. So what we did was we just did the 3 transformations and we stepped it through. And I did it using mapping and function. So let's go let f of x equal x squared. Let's do this by function first. So translation, 1 unit in the positive direction of the x-axis, 2 units in the positive direction of the y. G of x is equal to f of, so positive direction means we do that. 2 units in the positive direction of y means we do that. G h of x equals, so this is a dilation factor 2 from the y-axis. Okay, so to do that, I'm going to do f of x on 2. So I see x and I replace it with x on 2 to do the dilation. Take 1 plus 2. That's that. Reflection in the x-axis. So to do reflection in the x-axis, all I do is I negate the function. So h j of x equals negative brackets f of x on 2, take 1 plus 2, close brackets. Right, so now that we've got this, all we do is we just bang that into the function over here. So we say that j of x equals negative brackets x on 2, take 1, all squared plus 2, close brackets, like that. And that's going to be negative x on 2, take 1, squared, take 2. All right, so there it is via function. Let's do it via mapping. So x comma y maps to x plus 1, y plus 2. So that is positive direction. That is the positive direction. Cool. Dilation factor 2 from y changes the x values to x plus 1, comma, y plus 2. And the last one maps to reflection in the x-axis negates y, 2, x plus 1, comma, negate y plus 2. Okay, that's x dash and that's y dash. X dash equals 2, x plus 1. Y dash equals negative y plus 2. Okay, so what we want to do is sub x and y in, so we need to make x and y the subject. X dash on 2, take 1 equals x. Y dash over negative 1, take 2 equals y. Let's pop them in. So I've got y over negative 1, take 2 equals x on 2, take 1 all squared. Right, so what I'll do is add 2 to both sides. And then negate both. Y equals negative x on 2, take 1 all squared, take 2. So you can see here, both processes yielded the same result. I like to do it like this. Don't mind doing it via mapping as well. Okay, so for the graph of y equals x squared, determine the rule of the image under the following sequence of transformations. We've got the dilation, translation, and reflection. And you'll note that these are the same transformations. It's a dilation factor 2, translation 1 unit positive direction, 2 units in the positive direction, so that's that one, and a reflection. The only thing is, no, they're not the same. Order is different. Okay, and order matters when we transform, generally speaking. All right, so what we'll do is we'll go f of x equals x squared. Let's do the dilation first. So g of x equals f of x on 2 to do the dilation factor 2 from y. So g h of x equals translation 1 unit in the positive direction. So where I see x, I replace it with x take 1 all over 2. 2 units in the positive direction of y, that's that. J of x equals reflection in the x-axis means negative brackets f of x take 1 on 2 plus 2, close your brackets. Okay, so all we'll do now is pop them into f of x. So we've got j of x, our new function, is equal to negative x take 1 on 2, all squared, plus 2, all bracketed, equals negative x take 1 on 2, squared, take 2. So very similar looking, okay, but you notice that this part here, okay, although they look almost the same, they actually are two completely different functions. Right, it's up to you, Sophie, whether you want to do that via mapping for your notes or not, but I'm just going to leave it in function. I didn't do that one via mapping in class, I only did the first one. Okay, so two more problems. This one here, find the image of the equations under the following. Okay, so I've got f of x equals that, so I'm going to go g of x equals 6 units in the negative direction of the x-axis. So that's going to be f of x plus 6, 2 units in the positive direction of y. So f of x plus 6 plus 2. Reflected in the y-axis. So the way we reflect in the y-axis is we throw negative x into the functions. So g h of x is equal to f of negative x plus 6 plus 2. Okay, dilated by a factor of 3 from the x-axis. So jx equals 3 brackets f of negative x plus 6 plus 2, close your brackets. 1/5 from the y-axis means that what we drop in is 5x. So j k of x equals 3 brackets f of negative, and then for x, what we do is we drop in 5x to dilate by a factor of 1/5 from y. So 5x plus 6 plus 2, close brackets. Okay, so now we're ready to jam it all in. So we're going to go and say that k of x, our new function, is equal to 3 lots of 1 over, we're going to put negative 5x plus 6 plus the original 2 that was there, plus 2, close brackets. Okay, so where I've seen x, what I've done is thrown that on in its place, added 2, all multiplied by 3. So I've got 3 over 8, take 5x. 3 multiplied by positive 2 is positive 6. So there's my k of x function. Okay, and the very last question we did in class was this one here. So we started with a hyperbola and did this stuff to it. So again, just use the same approach. So f g of x equals, translated 5 units in the positive direction of the x-axis. So that's going to be f of x take 5, 3 units in the negative direction of the y. G h of x equals, reflected in the x-axis, negative f of x take 5, take 3, all in brackets. So that's the reflection in the x-axis, dilated by a factor 2 from the y. So h j x equals negative brackets f of, so to dilate by a factor 2 from y, I'm going to drop in x on 2, take 5, take 3, close brackets. Right, ready to go. So j of x equals negative 1 over x on 2, take 5, take 3, all like that. Negative 1 over x take 10 all over 2 after I found a common denominator, plus 3, because the negative is passed to there and to there, or distributed to there and there. Okay, dividing by a fraction is the same as multiplying by the reciprocal, negative 2 over x take 10 plus 3, and we're done. Okay, so what I did then was noted that these are the summaries of the transformations, and I really quickly ripped through this because this, in summary, this is a dilation factor 1/5 from y. Hopefully you know that by now. This is a dilation factor 3 from x-axis. This one here is a dilation factor 2 from y-axis. This one here is a dilation factor a from x. It's a translation. translation B right, and a translation C down. Okay, so the questions were 3D, those ones there.